Hi students, today we will learn about R and S configuration. The R and S configuration is also known as absolute configuration. It is used to tell how the enantiomers are arranged in space. So let's start. The R and S configuration was given by three scientists named R.S. Chain, Sir Christopher Ingold and V. Prelog. It is also stated as C.I.P. rule. C.I.P. rule. Chan for C, I for Ingold and P for Prelog. It states that the four atoms that are attached to the chiral carbon can be determined in a sequence of rules. We will learn these rules one by one. So let's see what does this rules tells us. Rule number 1. If the four atoms attached to the chiral centers are all different priorities, then it depends on the factor of their atomic number. So let's consider hydrogen and oxygen is attached to a carbon atom. So which will be considered? Oxygen will be considered because it has high atomic number. So it will be getting higher priority. Now rule number 2 says, in case if there is isotope, let us consider hydrogen and deuterium. H for hydrogen and D for deuterium. So deuterium has high isotope, high atomic mass. So it states that if the isotopes are present and if it is attached to a chiral carbon center, so which will be considered deuterium. So let's see in this example. Here we can see the carbon atom is attached to bromine, number 1. Then hydrogen is also attached, methyl group is there and deuterium is there. So the numbering starts with bromium because it has high atomic number. Then it comes carbon, then deuterium, then hydrogen. Why we took deuterium at number 3? Because we took deuterium at number 3 because its atomic number or atomic mass is high. So we took deuterium at number 3. Else we would have taken it at number 4. And now the rule number 3 states that if the relative priority of the two groups cannot be divided by rule mentioned above, then we look for other atoms. Suppose if the attached atoms are all methyl groups, see we can see here also it is, if we consider here it is R and it is R dash, though they both are methylic group, then we consider the next other atoms which are attached to that carbon. So we can see here 2 more methyl groups are attached, but here 2 hydrogens are attached along with an methyl group. So we consider which one we will take in priority. We will take the second one in priority and it becomes at number 3, and at the least the hydrogen comes in place. Now rule number 4. Rule number 4, what it states, if there is a double bond or triple bond, both atoms are considered to be duplicated or triplicated. So what does this mean? If we consider this aldehyde group, it's aldehyde functional group and it is attached to double O and H. So we can break it into 2 parts. We can see this. First, like this carbon is attached to hydrogen and whatever functional group it may be, then it is directly attached to what? Oxygen. So we have attached it to oxygen. Now oxygen is attached to both the methyl group, and now if we consider the oxygen, it is attached to both the oxygen itself and then to carbon atom. So it is carbon, not oxygen, it's carbon atom. And now when we take the triplet one, we can see, first we can see it's written like this, C dash, then it is attached to A, then A, then we have it attached to A, then to what the A is linked, we can see A is linked to carbon and carbon. And we will move further. Now let's see the two conditions which we will look in Fishcher projection. This type of projection is known as Fishcher projection. So in order to determine whether it is R configuration or S configuration, we will have to study these two cases. Case 1, if the fourth group is present on the top or bottom of the vertical line, then higher priority group, HP denotes higher priority group, to low priority group. If it is in clockwise direction, then it is R. R means rectus, right-handed. And low priority group, from high priority group to low priority group in anti-clockwise direction, it denotes S configuration or sinister, left-handed configuration. These both configurations, these both letters have been derived from Latin origin. So let's consider this molecule. Here the first numbering is been given to NH2, then carboxylic group, then methyl, then hydrogen. We can see the fourth group, the hydrogen is present at the top. So let's see how the 1, 2, 3 molecules are arranged. The 1, 2, 3 molecules are arranged in anti-clockwise direction. If it is arranged in anti-clockwise direction, so what we will consider it? We will consider it in S, it under S configuration. Now let's see the other molecule. Here we can see the amide 1, NH2 is placed with number 1, then carboxylic, then hydrogen, then carbon. So let's we shall also discuss why it is given number 3 and why it is given number 2, but according to atomic number it should be given more priority, na? Why it is given number 3 instead of number 2? So we have to consider the second attached atom also. We can see the oxygen is attached to carbon, but here we can see it is attached to 3 hydrogen atom instead of oxygen, so it dominates over this molecule. And we can see the one more C is there, and then it is attached to the other molecule, so it becomes it comes at number 2 position. And we can see the arrangement of 1, 2, 3 molecule. It rotates in what way? It rotates clockwise direction, so it is R configuration, rectus configuration. Now let's see, consider the case 2. If the fourth group is present on the left or right side of the horizontal line, if the fourth group, let's consider fourth group, then higher to lower priority, if it is in clockwise, it is considered S1, and it is higher to lower priority. If it is anti-clockwise, it is considered R configuration. So let's see the following molecules. We can see the oxygen OH, then ethyl group, then hydrogen. The fourth group is here at which position? The horizontal line, it is on the right side of the position. Here we can see it is on the left side of the position. So we can see it is rotating in clockwise direction. So if the fourth group is placed at the left or right hand side of the vertical line, and if it rotates clockwise from higher priority to lower priority, it is given S configuration. and in this we can see it rotates in anti-clockwise direction from higher priority to lower priority, higher priority to lower priority. We can see 1 2 3, it is moving in anti-clockwise direction, so it is considered as R configuration.